Okay, in this video we're going to learn about file I/O. The I/O stands for input output. So we've learned so far in Linux a little bit about files. Mostly we've used files that have character data inside of them, and that's what we're going to continue to talk about. The character encoding we've been using is ASCII. Actually it's technically UTF-8. ASCII is UTF-8 is designed to be backwards compatible with ASCII. Okay, but basically in ASCII, every 8 bits or every byte of binary data represents one character. Okay, and we can look at let me pull up the ASCII table. All right, so every 8 binary digits represents one character of data. All right, and in UTF-8 or in ASCII, well, in UTF-8, the first binary digit is a 0, and then you have 7 other binary digits. Okay, 2 to the 7th power is 128, so that means there's 128 different characters. So we have characters from 0 to 127. Okay, so these are all the different ASCII characters that you can make. And we're going to talk about how we can use Python to access files, and for our purposes we're going to just be learning about accessing files that contain character data. Okay, so that's why I brought up the ASCII table again. So every file that we open is going to contain character data, and that way we can convert that character data to a string and store it in a variable in Python. Okay, so that's the main point here. All of these files are going to contain UTF-8 characters. Alright, so first we need to learn about the open function. So because reading and writing data to files is so common in Python, Python has a built-in function for that called open. And we're going to open a particular file. Alright, so to open a file for reading, okay, you use the open function. So this is best understood with an example. So let me go ahead and open a new file, and we'll call this read.py, or we'll just call it open file IO. There we go. Alright, file IO.py. So what we're going to do is we're going to use the open function. Okay, and open is the identifier. It's a built-in function. Okay, so you can't use that for a variable name, otherwise it'll override this function. All right, and the first argument to this function is the path to the file that you would like to open. Okay, so I'm on my desktop here. If I want to open notes.txt, I can do that, and then you have to add a second argument. The second argument is how do you want to open the file? Do you want to open it for reading or for writing? If I want to read the data from the file, I need to add the string R, just a single character R. Alright, so what this function does is it looks in the file system, locates that file, and opens it, and stores a file object. This returns a file object, so you want to store that in a variable. So we can call that fn because we're reading in data. So the F might stand for file, and in stands for in because we're reading data in. So this is a file input. Alright, now if I want to read the data, I can make a variable called file data and set that equal to my file object, which is fin. Okay, open return to file object, and I called it fin. I saved it in the variable fin. So inside of fin there are attributes. One of them is called read. Okay, so I have my file object, and I call .read on my file object. So I'm reading the data that is stored in this file object, and I'm storing that string data in this variable called file data. Okay, now then I have to remember to close the file, fin.close. So that allows you to opens the file, and then I can read the data from the file, and then I have to close the file. This is important based on different operating systems. if you open a file, no other programs or processes can access that file while someone is using it. Okay, so this is important that you remember to close the file, otherwise it'll remain open for the duration of your program, and then you might not be able to use that file if your program doesn't terminate in a long time. Okay, so it's important, always remember to close the file handle that you have there. Alright, so these 3 lines of code should read in everything that's inside of notes.txt, and then I can just print it out to the terminal. Okay, let's print out file data. Alright, let's open a terminal, change directories to the desktop. Okay, first let's see what we have in here. We have file IO and notes.txt. First, let's just use Linux to see what's inside this file. So what Linux command can we have to look at what's inside a file? We use the cat command, and what do I want to look in? Notes.txt. Okay, and we see it just prints out everything that's in that file. Right? This is all the stuff we've been going over for this lecture series. Right? And if we look in Atom, we see that's true. We just look at notes. This is all the stuff that we've been going over. Okay, so basically what I'm doing with file IO is this is my own little version of the cat command. Cat does more than my program does. Cat can take multiple arguments, right? And actually my program doesn't even take any arguments. I have hard-coded in which file I want to open. But this essentially just reads in whatever's in notes.txt and then prints it to the console. Alright, so let's see. Let's run the code with Python 3, and then the name of the file is fileio.py, and we run it, and sure enough the same stuff prints out. Okay, so I have opened this file, notes.txt. I opened it for reading, right? I stored the file handle in there. I say get the file .read to read in the contents, to read in the character contents of that data, and store it in this variable file data. Then I close my file, and then I print out that data. So this is a very simple read. I can also write data. So if I wanted to, for example, make a copy of my notes, I use the open command again, or the open function, and I want to say this is notes.txt.bak for backup. So this little program might just back up my notes every time, just in case I make some changes that I didn't mean to and saved it. This will make a backup anytime I run this program. So what I want to do is I want to read in all the data from notes.txt and then create a new file called notes.txt.bak. Right? But this file I want to write data to. Okay? So this file doesn't exist yet, but I want to copy in everything from notes.txt and copy it into notes.txt.bak. Right, so if I'm writing data, I need to add the second argument to the open function. It needs to be a W for write. Okay, and this is fout, so that stands for file out. This is just a variable. I can call it whatever I want. I could call it file. This is fn. I could call it whatever I want. But this lets me know that this is a file and I'm using it for output. Okay, so I can use fout.write. What do I want to write into this file? Just everything I got from notes.txt. Okay, so I'm just going to write in, this is going to make an exact copy of everything I had in notes.txt, and it's going to copy it over to this backup file that I've named here. Okay, and then don't forget, always close your file. Alright, so let's clear the screen. So we still had that print function in there, so it still printed out everything in there. But now we see we have on the desktop here notes.txt.bak, and in Atom I have this backup file too. So I can look at that, and look, everything in here, this is an exact duplicate of my notes file that I've been making so far. Alright, so let's just rename this file. Instead of file IO, we'll call this backup notes. Alright, and we will delete this print. So now, literally all we're doing in this file is opening notes.txt for reading, getting the data from that file, closing the file, opening a new file, or if it already exists, we're going to overwrite the data in it, and the new file is this, and then we're writing the data we got from notes.txt into this file, and then we're closing that second file. And that's all we're doing in this, is essentially copying one file to another. Alright, so if we clear the screen, if I run this again, I changed the name so it's Python 3, and this is called backupnotes.py. Okay, and I run it, and it's copied everything. Let's test to see if that's true, if it's actually working. Let's add a bunch of gibberish here, save the file, we'll run backup notes. Now let's look in backup notes and see if that stuff's there. Yep, there it is. Alright, let's see if we delete backup notes, if it's still there. So let's delete that file, move it to trash. Okay, now we run backup notes. There it is, it appears right away. Is it the same stuff? It looks like it. Let's go to the bottom. Yep, there's all the junk that we just typed in. So if I change this, if I delete this and save, run backup notes, right? We'll look at notes, right? And all that gibberish disappeared. Okay, so this is file I/O, file input and file output. Okay, you can also append data. All right, so as another example in our notes, let's look at how to write data. So this is a quick little example of how to write something. Open a file for overwriting the data. So if the file exists, it will automatically overwrite any data in it. So I create a string, and it just says hello, and then this \n is an escape character. Okay, \n is actually one character, and it stands for new line. All right, and that tells the text editor or the terminal to go to a new line. Alright, so let's put this in here. We'll make a quick little program here, and we'll call this makefile.py. And we'll put this code in here. Alright, so this is going to take this string, and it's going to say hello, and then there'll be a new line. It'll ask how are you, new line, and then it'll say I am well, and then a new line. And then we use the open function to create a file called file.txt. We're opening it for writing, and if the file exists, then we will overwrite that data. If it doesn't exist, it will be created. Okay, so fout is just a variable that we're holding this file that we opened. fout.write, what do we want to add to the file? Just this string data that we have here. Okay, and then we close our file. So let's run this Python 3 make file, and on the desktop here we kind of smashed them together, but we see file.txt. If we look in Atom, we have it hello, new line, how are you, new line, I am well, and then one more new line, and you see there are 4 lines in this file. Okay, so that makes a file, and then we can read the file using this. Okay, now if I wanted to add something to the file without overwriting it, okay, so right now if I have file.txt, let's say I add a bunch of stuff in here and save it, if I run makefile again, the file is going to be overwritten. So Python 3 makefile, and now you see all of that stuff went away, because when I open the file for writing with this W, I'm saying if the file exists, overwrite all of the data in it when I call file.write. Okay, that's what that W means. Now you can open the file a different way and append data. If you're appending data, that means adding it to the end. So if I open it with the A flag, that's going to allow me to add additional items to my file. Okay, so let's look at that. Notes. So this will add last line of file to file.txt, and it will open the file for appending. That is quote A, and then we'll write that data. And since we opened this with the flag A, our data won't be overwritten. The data in the file is going to remain, and we're just going to add this new line in there. Okay, so let's make a new file here called append file.py, and we can just copy this code in here. Take a look at that. Alright, and we'll call Python 3 append file. Now let's look in file.txt, and sure enough we have last line of the file. If I call it again, now this is interesting because I didn't add a new line, it just adds the text at the end. Right? So really I should have added a new line here. So let's look at that. Let's add a new line character right there. Now when I run it, look at file.txt. Every time I run it, it adds a new line. Okay, so this is appending data to a file. Now this could be useful if you wanted to collect data from the user and you could append that to a file. Right? So let's start over and call Python 3 makefile. So this is our original file, and if I call append again, right, it keeps adding items to the file. So let's change append file a little bit, and we'll make it so we collect some user input. We learned how to do that last time. We could say s equals input, enter a line of text to append to the file and then give it a little space there, and then we'll say s equals whatever you typed in plus we're going to add a new line character. Alright, and then we're going to open our file and append whatever the user types in. Okay, so let's try this. Let's take a look at this. Let's start over here. We'll make the file again, and now we're going to call append. Enter a line of text to append to the file. Oh, I gotta run it. There we go. Run the file again. Okay, so every time I run this file, it asks me for a line of text, and I type something in and press enter. That gets stored in this variable s. Then I add a new line to s. So I take whatever was in s before and I add a new line character to it. Then I just open my file for appending with the A flag, and then I write that string to the file, then I close my file. So that's really all there is to file input and output, and you can use this in your future labs. This will be very useful, and this is one of the more common things to do in computer science. A lot of times you have to store data. When your program is running, everything in your program exists in memory. Remember, memory is volatile, so as soon as the computer turns off, everything that's been going on in your computer goes away. So what you can do is you can open a file and save the state of your program. So if your program is calculating some number or calculating prime numbers or something like that, you can be doing all these calculations, but as soon as the computer turns off or restarts, all of your calculations are gone. All the work that you've done is gone. So what you can do is open a file and save your progress, right? That's how it works in any kind of application or even video games where you save. Basically what happens is it takes the state of your program, all of the different values of the variables, and stores them in a file and saves it. And then when you open that file again, or you open that program and load your previous state, it loads all of the variables and puts them in the appropriate places in your program. Okay, so it's a really important aspect of computer science, file input and output. Okay? And it's great for data science, and it's great, like I said, for saving the state of your applications. Okay, so you will use this a lot if you're going to do anything further in computer science. So that's enough for file I/O.